In this unit, we're going to learn some special parallelograms, and they are rhombuses, rectangles, and squares. So first of all, let's look at the definitions of these three special parallelograms. Rhombus, in plain English, we also call them diamonds. So that's when you have a diamond-shaped parallelogram. Let's see if I can get this right. If I have a diamond, then my four sides are all congruent, right? Each of these four sides are exactly the same, and that's a rhombus. A rectangle is a lot easier to understand. Anything with any parallelogram with four right angles is a rectangle, right? Now the square is just one extension of the rectangle, and in a way combining the rhombus with a rectangle, that not only I have four right angles like a rectangle, my four sides are also exactly of the same length. They're all congruent. So these are the three special kinds of parallelograms that we're studying in this unit. So let's look at an example here. ABCD is a rectangle, and we're asked to find AD and AB. And then we have to find all the angles. Now, by definition, for a rectangle, my opposite sides have to be congruent. Therefore, my AD has to be congruent to BC. And here we said that the opposite side has to be congruent. I cannot spell today. And AD has to equal to BC, and BC is 5. And AB has to equal to CD, and CD is 8, where DC is 8. And all four angles, obviously, has to be 90 degrees, right? So this is strictly borrowed from the definition, and make sure you use the same method in your checkpoint. When you come back, let's look at some other theories and extensions of these theories. So we know that rhombuses have four congruent sides, but if I have a parallelogram that or quadrilateral, and I don't know if they're rhombus, how do I prove it? So if a quadrilateral has four congruent sides, then this quadrilateral is a rhombus. So in other words, here's ABCD. Look, all of these four sides are exactly the same. Therefore, this is a rhombus, right? Similarly, if a quadrilateral has four right angles, then I've got a rectangle here. And again, if a quadrilateral has four congruent sides and four right angles, like what it is here, then I've got a square here. So these are just an extension of the definition, and basically it's a converse. Remember, if we switch the conclusion with a hypotenuse, I've got a converse. So let's see, how do we use them. Here it says, use the information in the diagram to name the special quadrilateral. Ooh, I see four right angles. So the quadrilateral has four right angles. So by the rectangle, not rectangles, rectangle, corollary, this quadrilateral is a rectangle. Four right angles gives me a rectangle. And also because all of the sides are not the same length, you know this is not a square, right? If they're the same length, I would have got a square. And because they're not the same length, I know it's just a rectangle. It's not a square. So use the corollary, the rhombus corollary, rectangle corollary, and square corollary. Use those definitions and finish your checkpoint here. Here is a theorem, and this says the diagonals of a rhombus are, look at this, perpendicular. The diagonals AC and BD are perpendicular. So if we know that, let's see how can it help us. ABCD here is a rhombus, and we're asked to find x, which is this part of angle C. Now, because the diagonals of a rhombus are perpendicular to each other, therefore angle BEC here is a right angle. So BEC triangle is a right triangle. And by the corollary to the triangle sum theorem, the acute angles, the acute angles of a right triangle so in this right triangle, BEC, the acute angles are this 60 degree and the 90 degree. So they have to be complementary. Remember, complementary angles forms 90 degree like a corner. So therefore, since I want to know x, if I use 90 degrees minus 60 degrees, I should find my answer for x, which is 30 degrees. Okay? Next theorem. The diagonals of a rectangle are congruent. They bisect each other as well. We learned that in the last unit. But if I know, in this unit we learned that if I know that a rectangle, if it's a rectangle, they not only bisect each other, and if I call this M is the midpoint, they are also congruent. So AC is congruent to BD. Let's look at some examples in this one. My pen is getting tangled. My apologies. So there we go. So let's look at example 4. If you nail 4 pieces of wood together to build a 4-sided frame, so this is the frame that you're building. What is the shape of the frame? Now, if I build a frame, notice that opposite sides are congruent. So this has to be a parallelogram because both pairs of the opposite sides are congruent, right? Secondly, the diagonal measures 7 feet 4 and 7 feet 2. Is the frame a rectangle? And of course the answer is no, because the diagonals are not congruent. For rectangles, diagonals have to be congruent to each other. Make sure you finish all the all of these, the checkpoints and the follow-up, and all the answers. You can find all the answers or the clues that you need in the previous page. Okay, that's it, guys. I think we have one more shape in this chapter and then we're done. Thank you. Bye.